difference of the thing in the denominator. You've seen these terms numerator and denominator degrees of freedom. What these refer to is just what are the degrees of freedom in the thing in the denominator of the f-test. The thing in the denominator of the f-test here is the MSE. Its degrees of freedom are that. So that is the denominator degrees of freedom for that test. What is the thing of the numerator in the f-test? In this case, it will be A. The degrees of freedom of that are this, E minus 1. And so that is our numerator degrees of freedom. This is our table. I highly recommend that you have this in your formula sheet for exam 2. Can help a lot. So if this thing is significant, do not look at these two. If this thing is not significant, then and only then do you examine these two for significance. So that is our table. Exactly the same as the one that I drew up there for you guys. And what else do we know about it? We know that the f-stat for any of the treatments, for any of the treatment rows, so I've sort of just put a T here, for any treatment is just that treatment's row, MS, divided by the MSE. So for this one, if T is A over here, we get MSA over MSE. T is AB, we get this one over MSE, exactly the same way. MSE is the denominator for all of them. And they all sum up to the total SS, the sum of squares in all of these 4 rows together equal the sum of squares total. P-value. P-value is exactly the same thing as before, the same interpretation. You find the p-value by comparing each of these for your test with the critical F value. Critical value is found by getting the denominator degrees of freedom from the thing in the denominator and getting the, getting the numerator degrees of freedom from the thing in the numerator. Going to that table, finding that number, and seeing if your F beats that number. That is our process. And our reject or fail to reject is exactly the same as before. If our p-value is low, lower than our threshold, we reject. If our p-value is above the threshold, we fail to reject. If our F that we got is bigger than the one on the table that we looked up, we do reject. If the one that we got is smaller than the one on the table that we look up, we fail to reject. So how do we do this again? We look for the appropriate significance level, and we're going to have a few practice tries of this. We first look for the appropriate significance level on our table, get the right table, and then we find the denominator degrees of freedom and the numerator degrees of freedom for the things that make up our F statistic, and we go to that table, to those numerator and denominator columns, get the value. That is our critical value. It is exactly the same thing as in One-Way ANOVA. So the only difference here, the only difficult thing, 2 new extensions. Everything else is identical. 2 new things. First thing is, if you test the interaction and it's significant, don't look at anything else. The other extension is that the table is new, and there's some new stuff in the table. All the other principles are absolutely identical. And then finally, your conclusion, as always, your conclusion for the test. If you reject H0, you say that there is evidence to support the alternative hypothesis. And you put it into words. You explain it as if to your grandmother. You put it into plain English with no jargon. When I ask you to state a conclusion in one sentence, one complete sentence, I want you to give me some jargon-free interpretation of what you've just learned. Guaranteed to have a few instances of that on your exam. Don't write there, reject H0. That is not what I'm looking for. I want you to actually explain to me what this means in the context of the problem. And remember, when you report your results based on these 3F statistics, or just based on this one, if this one was significant, you were asking 3 different questions at once. So because you were asking 3 different questions at once, your conclusion should address everything that you were asking. So if, for example, in the heart attacks situation, this F value was big and so significant, in your conclusion you should tell me beta-carotene affects heart attacks and aspirin affects heart attacks. And they don't do it independently. There's some interaction between the way that they work. And you should explain to me that giving beta-carotene with aspirin changes the way that aspirin has an effect relative to when you don't give beta-carotene and aspirin. But both of them do have an effect on heart attacks. That would be the sentence we're going for in plain English. All right, so let's do an example together. Basketball example. The student is going to figure out if different footwear and different time of day matters for her basketball shooting. So in one situation she wears her favorite sneakers, these, and in another situation she wears not her favorite sneakers. I guess something more sensible. So let's see. So she performed an experiment to see if her favorite sneakers and the time of day affect her free throw percentage. She tried shooting with and without her favorite sneakers, and in the early morning and at night. So that's her data, what it looks like. For each treatment combination, she shot 5 baskets on 4 different occasions and recorded the number of shots made each time. So we're going to see, does it matter what kind of footwear she has? Does it matter what time of day she does this at? That is our goal. And do the 2 things interact? So first tell me the hypotheses. There were 3 hypotheses. Can you say them to me, please? Right, but as null hypotheses. Start again, but as null hypotheses. The time of day does not matter, correct? The footwear does not matter? Right, they do not interact. So different levels of them do not make a difference. Different combinations of levels of them do not make a difference. Perfect. And the alternative hypothesis is at least one of the things matters. At least one of the treatments matters. Any questions there so far? Great. Now, I'm going to give you guys a couple of minutes to work through this, and I'm going to walk around and help anybody who needs help. So I'm going to pause here. Okay, there seems to be a common source of confusion about how many observations there are. So what do we know? We know that she didn't record 1s and 0s. She recorded numbers out of 50 shots that she made. So she's not recording, here's my 1 shot, did I get a success or a failure, a 1 or a 0? She's not recording that. Her experiment is, for this session, I threw the ball a bunch of times, and I got this many successes. So for each session, so if you think about it, we're told she does each treatment combination. So what are the treatment combinations? The treatment combinations are sneakers and nighttime. We've got sneakers and daytime. We've got other shoes, let's call that O, in the nighttime. And we've got other shoes in the daytime. And she records 4 different observations for each one. And those observations look like 30 shots out of 50 and 27 out of 50. So how many total data points? Right, how many is that? 16. So N is 16. Excellent. All right, so hopefully that helps, and I will let you guys get back to it.